Hello everyone. Thank you for joining us for today's webinar. This is Neil Foley, the Applications Engineer at RISE, and today I'm going to be discussing how you can leverage the unique capabilities of RISE machines to add trust, traceability, documentation, and much more to your functional printed parts. Here is an overview of what I will be covering. We'll start with the basics of QR codes, what they are and how they're used. Then I'll talk a bit about RISE's patented APD technology and how it enables us to leverage QR code capabilities. Then I'll discuss some of the many useful applications of applying QR codes to parts. Next, we'll look at what is required to start using QR codes with QR code generators and scanners. And then we'll bring the pieces together and look at how QR codes are used in our RISE OneTouch software and the best approaches when using them. Finally, we'll discuss a few use cases of QR codes and the value they provide. The Quick Response Code, or QR code, is a simple pixel array that stores data and can be read by any smartphone with the proper QR code app. Similar to a barcode, QR codes span 2 dimensions, giving them a much higher density of data storage. To use a QR code, you simply scan it with a QR code reader and it will either display the embedded information or connect you to a linked web page. This capability can be very useful when applied to the surface of physical objects. A QR code can easily store information about versions, time and place of origin, and other metadata associated with a part. Information can be stored on QR codes in a variety of forms. Data can be stored as plain text, which is sufficient for basic annotation needs. Web addresses can also be stored in QR codes, which allows a code to link to virtually anything on the internet or a local network, including company websites, databases, images, and download links for files of any data type. This function gives QR codes another powerful capability. While a fair bit of data can be embedded directly into a QR code in static form, by linking a QR code to a web address, it can access an effectively unlimited amount of data. Furthermore, the data being linked to can be changed and updated dynamically, which is not possible for statically embedded codes. Dynamic QR codes will require an internet connection and their data can be lost if the web page is deleted. Next, I'll talk a bit about RISE's patented augmented polymer deposition technology. This technology offers a wide variety of applications as a scalable hybrid platform. So APD involves the simultaneous jetting of special inks and extrusion of our own compound of medical or engineering grade thermoplastic. So first, thermoplastic is extruded, forming the support structure. Next, release ink is jetted between the support and the first layer of the model structure, which eases the removal of the supports. Then, more thermoplastic is extruded, forming the model, and special inks are jetted between the layers of thermoplastic to control material properties by voxel. Using this approach, we are able to display text and images on the surface of parts by applying marking ink during the printing process. The marking ink capability can be used to print logos, annotations, or digital documentation in the form of barcodes or QR codes. Some parts could have a large amount of information associated with them, including part and version numbers, authors, dates, and printer of origin, as well as vital dimensions and their associated tolerances. All of this information could not reasonably be applied to the surface of a part using printed annotations, but with a QR code, all of this data and more could be applied to the surface of a part and accessed digitally. There are other benefits that QR codes offer that can't be achieved with typical printed annotations. By linking a QR code to a secure database with a gated login, any data stored on the part is accessible only by those with authorized access to the database. This allows parts to be annotated with classified or confidential information without exposing it to unauthorized users. QR codes can also be used for marketing or networking by embedding contact information in the code. This works like a business card attached to every part you print. And finally, QR codes can connect parts to their associated diagrams, instructions, and user manuals with much greater detail than printed annotations would allow. And we're not through with the variety of applications yet. QR codes are limited only by the information you have to attach to them, and therefore they offer great convenience and organization by attaching directly to your parts. So here are a few other ways that QR codes can be used. After creating a part with a dynamic QR code for design verification, you can document the results of the design verification on the linked page or redirect the linked page to your documented results. Thus, the documentation of testing the part will be attached directly to it for later reference. Another application of dynamic QR codes involves codes that link to instructions about the part, which may include procedures, diagrams, videos, safety concerns, and more. If for any reason a portion of the instructions is found to be incorrect or out of date, you can simply update the linked web page or file, and every instance of the linked part will thus be linked to the updated instructions. A QR code can also link to the model or drawing files that were used to produce a part, which can themselves typically document the dimensions, authors, dates, and other data about the part. And finally, since dynamic QR codes allow you to update the pages they link to, you could also use this capability for marketing or networking purposes, updating the linked web page to control when information will be available. Now, there are two types of programs involved in using QR codes. The first is a QR code generator, which takes a string of text as an input and produces the QR code pixel array as an image file. There are many generators available online, each with its own variety of perks. So this first link for the QRCodeGenerator.com is a good choice because it has a very straightforward interface and allows you to generate an unlimited number of codes. Some other QR code generators, such as QRstuff.com, have built-in functionality to create dynamic codes and will host the dynamic data. If you have already attached your data to a web page or network, you can use dynamic QR code functionality independently, and you don't need a site with that capability built in. Here at Rise, we are developing a built-in QR code generator for our desktop software and plan to include it in a future version. This will allow you to skip the code generation step, and it will streamline the process of documenting the metadata of your parts. Then concerning QR code scanners, if you have an iPhone, you are all set because a QR code reader is built directly into your camera app. If you have Android or another smartphone operating system, check the App Store for your phone to find a compatible app. So once you've created and saved the QR code image to your computer, you can import it into Ryze's OneTouch software. The software has an easy-to-learn user interface for processing files and applying markups. You simply select the markup button and choose the image on your computer that you would like to apply. You can apply markups to any surface, but for QR codes, it's best to apply them to flat surfaces with plenty of room. The larger the pixels are, the easier they are to scan, and they also need to be on a flat surface in order for a camera to read them properly. So to apply an imported image to the part, you simply rotate the view to the preferred surface and align the image to the part as desired. Once you have applied all of the QR codes and other markups you want to, you simply click to prepare the print job, and all of the text and images will be automatically processed and printed into the parts you produce. So here we have a brief video showing a QR code that is going to be applied to a part in Ryze software and then scanned. So you can see they are moving the view to the location they want the QR code and then applying it as an image. And then they prepare the job. And from here, the job is ready to send to the printer. Once it's finished printing, you can open a QR code scanner app in your smartphone, and that will bring up a table that's been created with information about the part. QR codes offer a lot of power, but there are a few things to consider to ensure that they perform properly. This slide has what you need to use QR codes successfully. One thing to be careful of is distortion of the code, which can happen when it's applied at an angle or onto a curved surface. The codes on the models shown here both became distorted due to angled application in one case and a curved surface in the other. These codes will be difficult for a scanner to read. To avoid the problem of angled application, you can use the normal to pick capability in markup mode. And what this is it lets you select a surface and the camera view will orient itself to face that surface directly. Another issue to avoid is obstruction of the QR code. The code shown in the model was applied to an inside surface. This will make it harder to read the code because it can only be viewed from an angle rather than straight on. For small obstructions, QR codes actually include an error correction mechanism that allows them to scan even if a portion of their data is hidden or damaged. But it's best not to depend on this. Shown at the bottom is a QR code template that shows the digital structure of the code. The gray area can be partially obstructed without rendering it unreadable, but all of the other colored sections need to be fully in view for the camera to see. Finally, each QR code image includes a white boundary that helps scanners isolate the code from its surroundings. So don't put QR codes too close to an edge, as is shown in the model, because this could also prevent the code from scanning. Here is a specific use case of QR codes. During a prototyping process, when a part or assembly is iterated through many versions, applying QR codes to each printed part can help keep the iterations straight. A QR code on each iteration can be used to document versions, dates, printing parameters, design changes, and much more. So, for example, if you've printed several versions of a part where each version requires a slightly different hole size, then just by scanning the QR code, a linked database can tell you the dimensions for each part. It could even connect you directly to the model file. This method can also document the relationships of an assembly among parts with different version numbers. Linking a code to your PDM system could allow a collection of printed parts of different version states to document their assembly state dynamically, rather than requiring you to reference and sort through an assembly tree for each part to determine whether it is still valid for the current revision of the assembly. Another benefit is that by linking to a database, in addition to changing the assembly relationships among the parts dynamically, a part can be digitally obsoleted, and that information will be available on the printed part itself. So for parts being produced and used at high volumes, this dynamic linking capability could allow you to instantly revise the linked instructions for every instance of a given tool or component. And here is another use case for 3D printed QR code technology. For a variety of medical reasons, doctors will use MRIs and CAT scans to model the bones and other organs of their patients. Printing these models in 3D is useful for visualizing the problem during pre-surgery planning, and it can also enhance doctor-patient communication. Now, QR codes can be a very useful tool in this case. A QR code applied to the surface of a printed model can link that model to a database of information about the patient, their medical condition, and the scan metadata of this particular model. Most importantly, that type of data is confidential. Linking the QR code to a secure database gives doctors convenient and organized documentation of printed patient models, but prevents unauthorized users from accessing a patient's personal information, even if they have access to the physical part. So this approach builds trust, traceability, and confidentiality into physical parts, which is valuable not only to doctors, but also to any organization with confidential or classified documentation of physical parts, whether they be models, prototypes, or tools. Now for a quick recap of what we've covered today. A QR code is a special pixel array image that can effectively store and retrieve data. Using them to mark up physical parts and models offers the ability to store a much higher density of information on their surfaces than typical annotations. And this ability can be used to store part numbers, metadata, dimensions, and plenty of other application-specific annotations. QR codes are easy to generate and read with plenty of free resources available online, and they're specially designed to read well even under imperfect conditions. And RiseOne's marking ink technology allows you to harness this broad functionality of QR codes for all sorts of applications involving your 3D printed parts. So that's all I have. Thank you again for attending today's webinar. I'll be staying online for a few minutes to answer any questions you may have about QR codes, APD, or RISE. So if you have any questions, please just type them into the GoToMeeting chat window, and I'll review and discuss them. And for more information, you can always reach me at applications@rise3d.com.